Good morning everyone. In this video we will be discussing about the tearing test on rubber, which is basically to improve the quality of rubber materials. So we will be following a proper standard in this, the ASTM standard, with the help of which we will be performing the whole test to showcase that how we can improve the quality. So why we should be focusing on the improvement of the rubber quality. So if I talk about the actual application of the testing which I will be doing, that is the tearing test on rubbers. Rubbers are being used as gaskets, they are used as footwears. So if I talk about a footwear only, so if we are wearing that, so after a long duration of time we expect that it should be remain durable. So if those kind of test has not been done on a specific equipment for the rubber samples, then the sample in actual actions may get rupture before we expect them to get failed. So that is why this kind of test is very important for the improvement of rubber. Okay, so how we will be performing the test, or if I talk about the tires also, tires we have, gaskets we have, so in those cases we expect the quality of rubber to be very improved. Now the standard we will be following for the test is ASTM D624. So in that case, two type of tests for the tearing test. It says the principle remains the same, that we have to use a CRT based equipment, that means constant rate of travel. We will be just tearing the rubber at a constant rate of 50 mm per minute or 500 mm per minute, and we will just see that what is the load taken to tear the whole sample, which will tell the quality of the rubber. So let us start the testing. So we'll first discuss about the specimen preparation. So first we have is a trouser type tearing specimen. This we have. So first the standard says for this kind of specimen, where we have to make a 150 mm long sample, 15 mm wide specimen, and this we have to make a cut mark of 40 mm. Okay, and we'll just fix the specimen in between a suitable gripper used for this testing, and we'll just tear it at a specific rate. That rate is also defined 50 mm per minute for the trouser type tearing test. So this is a rubber specimen. One type of testing is this. The second type of testing is with the help of a die we have to prepare this kind of specimen. Okay, this we have a type C specimen, okay, of this kind, and here the length, if I talk about in this term, this is 102, this is 19 mm, a 90-degree angle we have to maintain in this wing part. So this is how we have to prepare a specimen, and then we will be performing the test for this specimen also. This is how we have to prepare the specimen. So firstly we will be performing the trouser tearing test, where this specimen I will be placing. So this is how I will place it. The first end I have to fix here, then one end I will be fixing here like this. Now the grippers, you can see these are suitable grippers for the rubber testing. These are roller type grippers specifically for the rubber sample, so that we do not find any kind of slippage issues after the testing. So this is the WinTest software, so which Presto provides for the computerized tearing test. Okay, so we will be making a profile first. So the product name, so it is a rubber. Operator name you can set, batch, sample ID, everything you can set, and the testing speed. For the trouser type tearing test we have to set the testing speed at 50 mm per minute. The specimen is a strip specimen, the trouser. The length we have maintained is 50 mm, then width of the specimen is 15 mm, and the thickness is 4 mm. and the standard we are following is ASTM D624, and then we will be starting the test. So we can see that the sample has started tearing, and we can see the graph as well, and the peak load is also showing. So it is taking approximately 0.16, and elongation is also showing, although what matter is the peak load here. And we will wait until the sample fully ruptures. We can set here. Now if I talk about how to check the full test, if I talk about standard, the ASTM standard for calculating the tearing strength, right now it is showing peak load approximately 0.16 kilos it is showing. So if you want to make it in strength, then you have to divide it with the width of the specimen. Okay, so it means the load has to be divided with the width, and that too in meter. So the reading will be in kilonewtons per meter. The kilogram force you can convert in kilonewton, and the mm, which I have used mm, you can change it in meter. You will get in kilonewton per meter the tearing strength of this. So this is how we calculate the tearing strength. Okay, so we can see the load has decreased and the machine has stopped. So the result is 0.17 kilogram force. So maximum load of tearing is this. So this is how we need to check the tearing strength as per the trouser specimen, the sample. If the reading will be more for the specimen, it means that has a good quality. Of the good or bad quality, although it depends on the application. Either we are using this sample to make a tire or a footwear or a gasket, so all this depends. So now we will be performing the test for the die type C specimen, and then we will see how much load it takes. Now I will be fixing this specimen. So this is how we need to fix this. And it will tear at 500 mm per minute. Now I will change the specification. So now the specimen width is 19 mm, the length is 102 mm, thickness is same 4 mm, and this is a type C specimen as per ASTM D624. Now we will start this. So die C. Now I will start the test at 500 mm per minute. So we can see the graph as well and the result. So sample has torn and the result is 0.86 kilogram force, and the graph is also shown for this. So again, if you want to calculate the tearing strength, you need to just divide the result with the width of the specimen. So this is how we calculated. So this was about improvement of the quality of rubber in terms of tearing strength. So for more such information, you can contact Presto. Thank you so much.